Okay, let's solve another Java problem together. So it's still Java basic console applications. And we're looking at a population problem. So assume the population of Mexico is 121 million and that the population increases by 1.01% every year. Annually means every year. Assume the population of the United States is 315 million and that the population is reducing by 0.15% annually. Okay. Write an application that displays the populations for the two countries every year until the population of Mexico exceeds that of the United States. So when's it going to happen? Sometime in the future, if the trends continue. And display the number of years it took for the population to exceed the USA's population. Say the file is population.java. So let's go ahead and do that one. So it's an interesting little problem. There's no user inputs. We just need to worry about doing some simple calculations and some loops. Okay, so public class, curly curly, public static void main, string square brackets args, curly curly. Okay, so we might set up some constants. Whenever you got magic numbers like these, 1.01%, 121 million, 0.15, 315 million, they're all magic numbers. Rather than just put them in your program and not understand what they are, it's always better to just declare some constants. So public static final int. Well, actually, we might make it. We might make them all doubles because the population is not going to be a round number, is it? It's going to be a fractional number as well. So Mexico start population, or whatever you want to call it. That sounds like a good name to me. It's 121 and 123, 123. Okay, so you can keep the number in like that. That's 121 million. It's a bit hard to see how many zeros there are. So a little trick you can do with Java is put underscores wherever you want to. Okay, you can put them every thousands if that makes you happy, or you can put them every million if that makes you happy. I've got mine every thousand. So it just makes it easy to read the number. Okay. It makes it much harder to make mistakes when you put numbers in as well. USA start population. USA start populations 315 million. 315 million. Do we need to store? If you just want to deal with millions, we could just make it 121 and 315, and then you just put a comment there saying millions. So that might be even easier to deal with small numbers rather than great big long numbers. Okay, so then we got the increases, and I'll call it Mexico pop annual change, and that's 1.01. Okay, so that's percent. So the annual population change in Mexico is 1.01%. Now we want to make that a fraction, so we can just do the multiply later. So if we do divide by 100 here, that converts to a value between 0 and 1, which is much easier to handle later. So that's just no longer a percent. Okay, so 1.01 divided by 100. And then the USA, or else we can just leave it as 1.01 and remember to do the divide by 100s later. And USA pop annual change, USA pop annual change. And that's reducing by minus 0.15. Okay. And these are both percents. Don't forget, percent just means divided by 100. So 1.01% is 1.01 divided by 100. That's all I've done there. So I've just converted it to a fraction. That's what percent means, per 100. Okay, so let's create some fields. So we'll have a double pop Mexico. And that's currently equal to the starting population. Okay, and then double pop USA. And that's equal to the starting population for the USA. And the other thing we want is a year count. Int year count. Set that to 0. And of course, because I'm so fast, I've got to line everything up. Okay, so we want to keep looping. We want a while loop. We can do a for loop as well, but just ignoring two of the three areas of the for loop. We just can use the conditional part. So why don't we just use a while loop? While population of Mexico is less than pop USA, we're going to do a loop. Okay, so we'll keep looping while that's true. Okay, we'll keep looping until the population of Mexico exceeds the population in the USA, or until it's no longer less than the population in the USA. Sounds good? Okay, so the population of Mexico equals the current population of Mexico plus the population of Mexico times the rate of change. Okay, so the current population of Mexico, and it's increasing by 1.01%. So we multiply the current population by 1.01% and add it onto the current population. Same for Pop USA. Pop USA equals the current population of the USA plus the population of the USA times the rate of change, which is that value there. So we're multiplying the current population of the USA by minus 0.015%, and then we're adding that onto population of the USA, the current population. So it's going to be population of USA plus a negative number, so it's going to be effectively minus. We're taking a little bit off the population each time. Then we add one onto the year count plus plus. And then we're going to display, the question says display the populations for the two countries every year, okay, and then also display how many years it took at the end. Okay, so there's two things, or a few things we've got to display there. So system.out.println, and it's going to be year plus year count. So we can display the year count to the screen plus, and then we'll put a tab in, and then we'll display Mexico in quotes plus Pop Mexico plus tab plus, and then don't forget a plus at the end of the lines because we've got another line coming after it. Don't forget the pluses here, and then USA plus Pop USA, round bracket, semicolon. And then right at the end we can say how many years it took. So that's going to display the information for each country every year as we're looping through the loop. And at the end we want to say how many years it took. System.out.println, it took plus year count plus years. So we can tell the user how long it took then. Okay, that looks pretty good to me. We've got the population set up, the starting populations, the rates of change. We've got fields to hold the current values of the populations. Oops. And the year count. And we're looping while population USA, or population Mexico is less than the population USA. Working out the new population change at the end of that year, if the current trends stay the same. And Pop USA as well, adding one to the year count. Displaying the results to the screen every time through the loop. And at the end we'll display how long it took. Pretty good. I don't think we've missed anything there. Control 1, Control 2. Wow. Okay, so we've got the results already. So you can see it's scrolling through, and it took 83 years. Now there are some things we can do to improve this. These numbers are quite hard to read with that many digits, so we can shorten the digits. And we can make it so everything lines up nice and neatly in columns rather than jumping across and weaving in and out. And the numbers here as well. See, they jump in and out. So we'd like the digits to line up above the 0 there, not above the 1. Just if we wanted to, just be a little bit fussy. It's very easy to do. There's a function called string.format, and you can apply that per field, or you can apply that to a bunch of fields at a time. I want to do it per field, just to keep it simple. Okay, so we want to format this year count there to 2 digits, and the first digit is going to be a space. So it's going to be string.format, and then inside quotes here we put double quotes and then a comma. So that's saying, and then a round bracket at the end. So this is saying we're going to format this bit of data. Okay, and in here's where we put our format string. We'll do the same thing here for the next field, and round brackets, and we'll do the same thing here for Pop USA. And don't forget your extra round brackets. You need round brackets at the end, and then round brackets to close this system.out.println statement. Okay, so how do we want to format the year? So you've got to use a %. %sign gives me means give me some data, and we want to tell Java we want an integer. So the symbol for that is a D. D is a decimal integer. Okay, so year count's going to be formatted there, and we want 2 digits, %2D. Okay, so it's really hard. If we wanted 5 digits, it'd be %5D. Okay, we just want 2. Okay, now for floating point numbers, it's percent, means give me some data. Dot to F means 2 decimal places, and it's a floating point number, so a number that's got decimal places. Okay, and then we give that same format to the next field as well. So don't worry about these formats too much. We haven't really covered them in class yet, so but by the end of the term you're going to be really good at them because we're going to be using them a lot. So D means decimals or integers, F means floating point numbers, and you can specify how many decimal places you want. And if you wanted a 1000 separator as well, you could put that in as well. Just go comma dot 2F, and that means give me the 1000 separator as well. We're only dealing with numbers that are less than 1,000 million, that is. So we don't need a decimal plot, the 1000 separator. Let's give that a try and see how neat our output looks now. Control 1, Control 2, and you'll see we've got the 2 decimal places, which is much nicer, and everything lines up beautiful. See the digits line up above the 0 all the way to the top. So I've got a beautiful little chart there. If there's one thing that I might change, I might want to put a bit more space in there between that figure and a USA label. We can do that as well. Still took 83 years, but everything's looking nice and neat. Okay, much neater. And what we can do is just put a couple of spaces there if you want. Control 1, Control 2, and there we got things spaced out a bit nicer. So it's 83 years. If the current trends continue, Mexico's population will exceed the USA's. Of course, that's a big if current trends continue. Mexico's developing like crazy and going ahead in leaps and bounds. And that could be a new world power in 83 years' time, and their population growth might slow down like other highly, more developed countries maybe. So anyway, that's that little problem. I hope that's been useful. Nice little problem, that one, just to explore some simple calculations and a simple loop, and of course using constants. Don't forget that all your magic numbers should go as constants, so you don't have magic numbers in amongst your code and people wonder later on what does that number mean. When you've got a constant like that, it's really easy to tell what it means. Okay, anyway, hope that was useful. Thanks for watching. Have a nice day.